Okay. Today's lecture is on mechanical methods of weed control. Here I've got a slide which is showing maize with the weeds. You can see the rows of maize, and in between there are weeds there which have to be removed using mechanical methods. So on mechanical methods, we are really focusing on the use of machines or chemical devices driven by animal or fossil fuel energy to control weeds. These days, we are moving from conventional tillage to conservation farming, which means our methods may have to change so as to suit conservation farming. But I'm going to talk about weed control in both, probably in both systems, or probably mainly in the conventional tillage. Now, there are three important stages where we are going to focus on the mechanical devices which are used in weed control. First, there is land preparation. We are going to talk of what sort of equipment can be used under land preparation. Then we also move to planting time. What sort of equipment can be used at planting time? Then after crop emergence, let's say 2, 4, and 6 weeks after crop emergence, what sort of suitable equipment can be used to remove weeds? So I want to start with pre-planting tillage. This is done to remove existing plant growth and create a clean seed bed. So all the plowing operations which are done, we are trying to prepare a clean seed bed, and probably we will kill weeds such as Cynodon dactylon, Cyperus esculentus, Cyperus rotundus, and the Coniza species. These are some of the weeds which can prevail during plowing times. Now, what plowing does is to bury weed seeds at a depth from which they will fail to emerge. If they try to emerge, they may die through suicidal germination because they will run out of carbohydrates, which is required for growth. Now, weed seeds may be forced to go in a state of dormancy if they are buried at a greater depth. And some of the weeds which have been previously buried are brought to the soil surface. They break dormancy and they may germinate when moisture is sufficient after the onset of rains. So this is the sort of equipment which is used for removing weeds pre-planting tillage operations. So this is just a mold body plow which is tractor pulled. This one is a disc harrow which is used for plowing to prepare the seed bed, but at the same time killing weeds. Both plows do the same thing. This one is an ox plow, which is also used to remove weeds and prepare the seed bed. This is an unusually big ox plow with it can take 2 furrows at a time. This could be too heavy for animals. So this is the tractor plowing operation. Here we have got the ox plow. Normally, some people will remove what is known as the hitch assembly. So if it is removed, sometimes it's difficult to handle the plow, because farmers say the hitch assembly is heavy for animals. But if they remove it, then it becomes very difficult to plow. So this is plowing, burying the trash. If there are weeds, they will be destroyed during this operation. You can see they are plowing and planting. This is a planting behind the plow. This is a disc harrow. After plowing, you can run it to create a smooth seedbed. Or after plowing, there could be some weed seedlings. Then you run the disc plow to kill the weeds. So disking can break large clods. It can kill weeds. It can expose weeds on the soil surface. These can be killed by desiccation. And I want to talk about what is known as fast, shallow cultivation. This operation is done using harrows. We can target the first flush of weeds because they are more competitive than the subsequent flushes of weeds. The use of the harrow may not be effective under wet conditions. It can also not be effective against big weeds. We may also use this operation to incorporate herbicides. So for the fast shallow cultivation, we use the spike to the harrow, which can be tractor drawn. Or we can use the spike to the harrow, which is animal drawn. This is a spike to the harrow, which is animal drawn. What we can do soon after planting or at emergence, we can run this harrow to kill weeds. But some farmers think that they may damage their crops, so they avoid using the harrow. So the spike to the harrow, it can be ox-drawn or tractor-drawn implements. They are rectangular or triangular steel frames with the spikes attached. These spikes could be 5 to centimeters with a sharp end. These are the ones which remove weeds. Spikes can break the soil surface and uproot weeds. Weeds are actually exposed to the soil surface and they are killed through desiccation. And the weeds can germinate from the first 2 centimeters layer of soil. And it is these weeds which are vulnerable or which are targeted by the sharp spikes of the harrows. But the crops can emerge from 5 centimeters, a greater depth. So there is selective killing of these weeds since the harrow is targeting the 2 centimeter depth. So we don't expect crop damage, because this operation is just done before crop emergence. We have what is known as rotary cultivator or millipede. It's simply an axle fitted to blade, gently pluck the weeds. So it can be done before crop emergence or at crop emergence. Again, this is the rotary cultivator. You can see this axle containing blades. So you run this or drag this in the field to kill weeds. Before crop emergence, you can run this with a tractor. Again, the rotary cultivator with these blades, which are designed to slash or take out the weeds. So the rotary cultivator could be tractor drawn. It consists of several rows of rotating fingers mounted shaft on a steel frame. So you have a shaft and you have got these blades which are fitted there. These are the rotating fingers or blades which have a gentle plucking and the lifting effect on the weeds. Where I wonder whether this is gentle plucking. Weed seedlings may be plucked out by this rotary cultivator. Now we move on to what can happen after crop emergence. We now need different types of equipment. In this case, we are doing indoor cultivation. We want something which goes between the crop rows and remove weeds. So in indoor cultivation, we are removing weeds from the between row area. This is the between row area. This is the crop row. So we are targeting this row. Now at 60 centimeter crop height, there may be crop damage, as was reported by Chivinge in 1990. Now, under wet conditions or humid conditions, cultivation is a bit difficult, or it may be impossible. Another thing is that weeds in the row have to be removed by hoeing or hand pulling. You may find that there are weeds which are growing within the row. You may have to hand pull them, or you may have to use a hand hoe. The advantage of ox cultivation is that it can reduce labor required for hand weeding. Another thing is that ox cultivation can create a rough surface which enables water conservation. So it's an advantage for the crops. This is an example of ox cultivators. You can see they have what are known as tines. And this one is fitted with, we call this healing blade. This is a tine. At the end, we have what is known as a dark foot tine. Of course, you have a wheel in front. You can adjust the depth of the cultivator here by shifting this part which is attached to the wheel. And here you can adjust the width of the ox cultivator using this lever. You can push it inwards so that you have, if you are working in narrow rows, which is supposed to remove the weeds. Usually it's at the back of the cultivator. These are some of the cultivator tines which remove the weeds. So basically, tiny cultivators have got 5 tines and move between the and are targeted in the between row area. That is where they remove their weeds. The types of tines which are available, we've got the shovel tines and the dark foot tines. The shovel tines, maybe they are these ones. And this is the dark foot tine. Now, a lever is used to adjust the cultivator width. Either you move it outwards or inwards in the between row area, depending on your row width. The ox cultivator is very efficient in removing weeds when they are less than 15 centimeters, probably in height. Now, sometimes you have the problem with animals which tend to graze your crop. So they are fitted with what are known as mouth guards. This one is a tractor drawn tine. You can see it has got a lot of these tines, which they are fitted on a steel frame so that the steel frame can push the tines inside the soil. Then this is dragged by the tractor. That operation will remove weeds. So this is the tractor drawn tine. The tractor drawn tiny cultivator. It has these steel frames where we fit the tines, and this steel frame provides the weight which pushes these tines inside the soil. This one is an adjusted tine cultivator. You can see if you have got narrow between row areas, you can use probably 3 tines which are targeted to the area. And this is dragged by the tractor. Now the tractor drawn tiny cultivator can cover 2 or 4 rows at the same time. Now the tines are, they have a spring material so that if they hit obstacles, they are not stuck. They are not going to break because of this spring material. And as I have shown you, tines are mounted on a steel frame. Now let us move on to the ox-drawn plow, because it can be used post-emergence for removing weeds. And most smallholder farmers own plows in Zimbabwe. And we can use the moldboard plow to remove the between row weeds. But the plow has to move twice, unlike the ox cultivator, in the between row area, because the plow is taking a single furrow to remove the weeds. So the weeds are directly removed in the between row area. What can happen is that those in the in row may be buried by the soil, and in the process, they can get killed. The ox-drawn plow can also create ridges, and these ridges have to be tied. You have to block them so that you create moisture conservation structures. Probably this is quite ideal in natural region 3, 4, and 5, because you need the water harvesting techniques. These are dry areas. Rupende et al. In 1993 reported that the ox plow was reducing the parasitic weed infestation in the maize in Chinyika resettlement area. Now, I just want to indicate that there are some farmers who remove what is known as the mold body breast. Some people call it locally dish or something like that. Now, the reason why they remove it, they think they will make the plow less heavy for the animals. But the disadvantage is that instead of having 2 passes in the between row, you may end up doing 4 passes, which could be time consuming. And also weeds in the row area may not be controlled. So you need to supplement with hand hoeing or hand weeding. Another disadvantage of doing that is that this cannot create moisture conservation structures. So the result is that you have dry soil profiles after this operation, and this can expose the crops to excessive drought conditions, and thus reducing crop yields. So the technique of using the ox plow is very important. If it is not used properly, it can actually decrease crop yields. We also have ridges, which look like plows. This can be used to make ridges in tobacco, and at the same time, they will be removing weeds. So this is a tractor-drawn ridger, which can be used just like a plow to remove the weeds, or it can be used like an ox cultivator or simply a cultivator. So this is the ridger, which is tractor mounted. This is the animal drawn ridger. Probably these are used by some smallholder farmers growing tobacco, because you need to create some ridges. Well, ridges are rarely used by smallholder farmers. They are not popular because they require high draft power requirements. Probably they are too heavy for the animals. Instead of using 2 oxen, you may require maybe 4 for this type of equipment. But the advantage is that they throw soil in opposite rows and create ridges. So you have tractors which are commonly used to make ridges in tobacco and the paprika. Probably otherwise, some farmers will just use plows to make ridges. Well, this is an ox plow without a hitch assembly. And the hitch assembly is the one which is put in front of the plow to make it steady. So if you, again, farmers remove this hitch assembly, saying that it will make the plow light, but it will make the plow very difficult to control. You can see this person is struggling to use this plow. Actually, you can use one hand to control this plow if the hitch assembly is there. In other countries, they can use one oxen and they have very simple plows. This is what is known as a gang tiller or rolling cultivators. You have a rotating drum which is pulled and it has some spikes which hit the weeds. These are on a steel frame, and this piece of equipment is tractor drawn and it can be dragged in the field. Again, the gang tillers, rolling cultivators, they just look like cultivators, but they are now modified, you know. You have drums with these spikes. A closer look at the gang tiller, it has this frame. And you have this axle. Fitted to it, you have got these sort of blades which remove the weeds. So as it rotates, it's actually removing the weeds. And you have a plenty of these fitted on a steel frame, and they are targeted to the crop rows. Again, the rolling cultivator, you can see they are now targeted to the space between these crops. The rolling cultivator in operation, you can see they are targeted to the narrow rows. This could be soybean crop. And you can run this machine hitting the soil to remove the weeds. So the gang tillers or rolling cultivators are gangs of tillers on a toolbar. You have a shaft on which is mounted a heavy drum with hooked prongs, which dig out the weeds. Now, hand weeding or hoeing. This is the common mechanical method. And these are the types of hoes which are used. This is hand weeding in maize. You can see this is red weeding. The maize is already tasseled. I don't know what sort of yield we can get from such a maize, but you find people are still weeding. They ought to remove these weeds, even if they may not harvest anything. So you have a group of people doing hand weeding. This operation requires a lot of labor. So hand weeding or hoeing. Now, hand weeding or hoeing, this is the common control method in smallholder farming areas, where farmers use hoes, iron blades attached to wooden handles. Now, if you have got weeds which are close to the crop row, they have to be hand pulled because the hoe may damage the crop. Hoes can be used while bending. This is not an easy task, and it can require 200 to 400 man-hours per hectare, as was reported by Gill in 1982. Now, hand weeding or hoeing is very difficult under wet conditions. It is very slow. I've said that it can require up to 200 man-hours. It's labor intensive. Most crops need at least 2 weedings. Now, smallholder farmers spend nearly 50 to 70% of their total labor for crop production in doing hand weeding. It is cumbersome and inefficient, and also timely weeding is very difficult to achieve, simply because there are labor bottlenecks which occur around November and January. Sometimes the farmer is supposed to plant more crops at the same time. The early planted crops require some weeding. So sometimes farmers prefer just to go on planting because they are chasing after the moisture, which sounds reasonable. In most cases, farmers fail to complete hand weeding. You see fields which are abandoned because they cannot sustain hand weeding operations. This method is also associated with spinal problems. One of the problems with the mechanical methods or hand weeding is that you may be confronted with weeds which are similar to your crop. For example, finger millet, Erosine coracana, and Rapuco grass, Erosine indica, they may look the same. So it's very difficult to differentiate. You can also be faced with the Rhodobolia coccinensis, chamber grass, which looks like maize. Then you can also have stock rose, which is hibiscus musae, which looks like cotton. So mechanical methods become very difficult. So I just want to summarize this lecture on mechanical methods of weed control. What you need to remember is that there are probably two stages. The first stage is land preparation. What sort of implements do we need? We need the mold body plow, the disc plow, or the disc harrow. Actually, I'm going to talk of 3 stages. So at land preparation, these are the suitable implements to remove weeds. And we are simply trying to create a smooth seedbed. Then at planting time, but before crop emergence or just at crop emergence, we can come in with the spike to the harrow to remove the weeds. Remember, the weeds are emerging from a 2 centimeter depth, and they usually take 3 days when they are exposed to moisture to germinate. So they can germinate earlier than the crop, which is coming from a depth of 5 centimeters. So it is the differences in the time of germination which we can capitalize to target the spike to the harrow so that it can selectively kill the weeds before the crop emerges. Sometimes we can use the millipede or rotary cultivator. It's safe to do so, although sometimes farmers, are a bit hesitant to use these pieces of equipment because they are afraid they may damage the crop. Then when the crop is emerged 2, 4, 6 weeks after crop emergence, we can use tractor-drawn tiny cultivators. We can also use animal-drawn cultivators. We can use the ox plow. We can use ridgers. There's also an opportunity to use what are known as gang tillers or rolling cultivators, which could be very effective in removing weeds. And above all, we can use hand hoes. Usually from 2 weeks after emergence and throughout the season. Probably we may need 3 weedings per cropping cycle. Or we can weed before crop emergence. So this is it on the mechanical methods of weed control. So I will end here. Hello.
Hello, Doc. How are you?
Fine. Any questions?
None from me, Doc.
Okay. So this is our first lecture on. Did I send the PDF?
I haven't received it. Maybe if you have sent it on a mail, I haven't checked it yet.
Probably I will send it again on this site.
Okay.
Yeah. There's also a lecture on physical methods of weed control. Maybe it will become too much if we go through it.
How long is the stuff?
Maybe we'll finish at 5.
At 5? I don't know if my
But I don't want
colleagues are
to
comfortable.
offload a lot of things. Maybe we just want to focus on mechanical methods first.
Grace and Pimpai, what's your take?
Hello.
Do you want me to proceed to another lecture, or for today I leave it there?
As for me, I am at home, saka I don't know kune vari kumabasa kuti vanenge vachiti kudii. But
Those who are at work.
I'm home too.
It's okay, you can proceed.
Okay, let us proceed to the next.
Okay.
Okay. So the next presentation is on physical methods of weed control. Now, in some textbooks, they don't differentiate between mechanical methods of weed control and the physical methods of weed control. Probably this may become clear when we go through what we call physical methods of weed control. But in mechanical methods of weed control, we are really emphasizing on the type of equipment which is used to remove weeds before planting, during land preparation, then soon after planting, but before emergence, and as from 2 weeks after emergence up to probably 6 weeks after crop emergence. Now, when we talk of physical methods of weed control, in most cases, we are looking at the use of things like water. How can we utilize it to control weeds? I know in Zimbabwe, we do not have plenty of water to say we can use it for weed control, because we have got a lot of dry spells. Fire, yes. We can use fire to burn weeds. Steaming, this is the use of steam. And we'll see whether we can really apply this method. Then frost, we know we've got frost like in this month, in June, where frost can kill weeds in wheat. This is just an opportunity, because wheat happens to be grown in winter. Then we have got mulching, which can be used to kill weeds in conservation agriculture. Solarization, this could be the use of plastic sheeting, which can be expensive because you need to acquire the plastics. Then gamma radiation, this is use of radiation to stop germination. This can be a very expensive process. Electrocution, use of electricity. I don't think in Zimbabwe we can afford to use electricity for weed control. So let us talk about flooding. This is mostly applicable to rice. Now, where rice is being grown, especially in India and some other countries where they can flood their fields. During the flooding, weeds can be killed because rice can tolerate these floods. Probably even in this country, in Zimbabwe, we've got rice being grown in flay areas, which accumulate a lot of water, and probably most of the weeds may not survive under such a situation. This is flooding in rice, where water is suffocating most of the weeds, leaving rice which is tolerant to the water conditions. So flooding can simply create conditions which are not suitable for plant growth. For example, it can create anaerobic conditions which cause death of roots and shoots. Rice can be grown in standing water as well as dry land conditions. Rice can tolerate flooding than most weeds. So many weeds cannot germinate under flooded conditions. And the rice can, escape weed competition. Of course, we can have some floods in some of our maize fields, but these floods are not conducive for maize production, so they tend to damage both weeds and the maize. The crop needs to be tolerant to the flooding. This is a flooded crop. This is not a good environment for some of our crops. But for rice, it can thrive under flooded conditions. In most cases, we actually need water. And you cannot afford to use water to kill weeds. We want water for plant survival. Let us look at burning. Well, burning is simple. If you have got plant residues, you can you can burn those residues. Then they will be able to clear some of the agricultural fields. In most cases, wheat and barley straw are sometimes, burned to allow rapid planting. There could be periodic burning on a rotational basis, probably as a management strategy on the cattle farms. So you want new grass to be grazed by animals. So this is burning. Sometimes it's not good because it kills everything. And sometimes it may get out of control and you end up burning what is not supposed to be burned. In some countries, they actually use some machines which are designed to burn weeds. They are called flame burners, which are directed to indoor raw weeds in cotton, maize, and lucerne. So you have flames which are fueled by natural gas or liquid propane, which may increase temperature within the weed, causing cells to rupture and effectively killing the weeds. It's like cooking these weeds with the flames. So weeds are more susceptible to heat at 3 or to 5 leaf stage. So you have a burning of weeds near the crop rows, directed flames. This is done in some other countries, not in Zimbabwe. And of course, if you look closely, sometimes the maize may be damaged. These are the weeds, Canopodium album, in the background. So this is the piece of equipment which is used for burning weeds. So the other method is steaming. So you need to heat water to produce a lot of steam. Then this steam is passed through the soil to get rid of weed seeds, diseases, and pest propagators. Probably this can be done for high value crops like ornamental plants, mushrooms, and nursery plants. I don't think this is feasible on a large piece of land. You can do this probably in glass houses and the small pieces of land where you are growing some nursery crops. Frost, we get frost like this month in June, July, and sometimes in August. Now this frost, which is occurring probably now, is responsible for reducing weed problems in wheat and barley grown in Zimbabwe as from May to September. So this is naturally occurring frost. I think in the high veld, frost can actually control the weeds. It may not be necessary to spray the herbicides in wheat. In the low veld, where it is warm, and other areas where it is warm, probably frost may not be very effective. This then is wheat. We should remember that there are some weeds which are tolerant to weeds. For example, Canopodium album, Galensoga parviflora, and the Avena facial. These may not be killed by frost. So if you do scouting in your fields and these weeds are prevalent, you need to use herbicides to control these weeds. But if you have weeds like Edesina indica, Amaranthus hybridus, and the Hibiscus missae, probably these can be easily taken out by frost. You may not need to spray herbicides. In fact, in most cases, the data for weed-wheat competition reflected that it was not really necessary to control weeds in wheat in frost-prone areas. I wanted to talk about mulching. Now, mulching is any type of material that is spread or laid over the surface of the soil as covering. Mulching forms a barrier which prevents the transfer of light, heat, and soil moisture. It's put on the soil surface. Here are types of mulches. We've got the plant residues, crop residues, leaf litter, grass, plastic, polythene sheets. You can have a clear or a black polythene sheet. Then you can also have live mulch, which can be grown as an intercrop. What we have here is a crop, and there's a bit of a mulch, which is covering the soil. Now, what are the benefits of mulching? First, they can suppress weed growth. Second, they can regulate soil temperature. There could be reduction of soil loss through erosion. Then conservation of soil moisture. They can also add organic matter. They can also add nutrients to the soil. Now, we have conservation tillage. Probably the right name is conservation agriculture, where we have a tillage system which leaves more than 30% covered by crop residues. And about 60% of the large-scale commercial land was under some form of conservation tillage. Now, if we leave crop residues as mulch on the soil surface, they can actually reduce weed germination and growth in two ways. First, there is aridopathy. There are some mulches, especially wheat and sorghum, which can produce chemicals, which kill weeds. Secondly, we have weeds which require light for germination. We call these photoblastic weed seeds. Now, if these seeds, which are mostly found on the surface in conservation agriculture, if they don't have light, they are going to fail to germinate. What the mulch does is to create dark environments on the soil surface. In fact, the weed seeds can sense light through what is known as phytochrome. And this phytochrome occurs in two forms. We have got the phytochrome red and the phytochrome far red. So if we exclude light, the phytochrome far red, the phytochrome red is converted to if we don't have a light, sorry, the phytochrome far red is converted to phytochrome red, and the phytochrome red will send the seeds into dormancy, and these seeds are not going to germinate. So as long as there is a mulch, the photoblastic seeds will not germinate. This is as opposed to what can happen when you remove the mulch, where you have the phytochrome red being converted to phytochrome far red, which breaks dormancy and causes a lot of wheat seedling emergence. Now, we are talking of wheat seeds which are on the soil surface. What about the wheat seeds which are large, which can germinate from, let's say, 5 centimeters? Now, when these seeds germinate, they don't really require light. They are going to germinate anyway in the presence of mulch. But when they want to emerge from the soil, they will be killed by a process known as etiolation. Etiolation means these seedlings fail to form chlorophyll, so they remain white, which means they are not going to photosynthesize. If they are not going to photosynthesize, they are not going to get carbohydrates. So these seedlings will spend most of their time looking for light, and they will run out of carbohydrate resources, then they die. So as long as there are crop residues or mulch covering the soil, there won't be any weed seedling emergence. So for effective weed control in conservation agriculture, if farmers could focus on the accumulation of crop residues, I understand now they are targeting small areas, something like 39 meters long and is it 16 meters wide. Surely they should be able to find mulch to cover these small areas where they call Pfumvudza. In fact, it may not be necessary to weed if mulch is used effectively. So apparently there are 3 ways which mulch can kill weeds. It can be through aeropathy, where the mulch itself produces aerochemicals, or it can be through alteration of light. Photoblastic weeds will be sent into permanent dormants. They won't be able to germinate. Those which try to germinate will be killed via etiolation. They won't be able to synthesize chlorophyll so that they can photosynthesize and become self-sustaining. So crop residues, mulch is very, very efficient in reducing the weed problems, especially on the conservation agriculture. If you had forgotten, aeropathy is, the production of aerochemicals via leaves or roots.
Sorry.
Yeah. So these aerochemicals, sorry about the disturbance, they can actually kill the weeds. Crop residues have been reported to kill weeds, for example, oats, barley, sorghum, wheat, and rye. So these are some of the aeropathic effects on weeds by wheat straw, also sorghum, and the multi-purpose tree mulch. Even soybean residues were also found to decrease weed seedling emergence, as reported by Mashinga et al. 1985. So in conservation farming or agriculture, or Pfumvudza as they are calling it now, has got probably 3 pillars or three operations. You have got, you just put in furrows or planting basins. Then you certainly need the mulch retention. This is the key to weed control in conservation agriculture, the use of the mulch. Then you need to rotate your crops. You may do intercropping with legumes, but the most important thing is to do crop rotation. But because of the planting methods, probably this requires a bit of research so that people look at the crop spacings of some of these legumes. This is conservation farming or agriculture. You can see the farmer creating planting basins. Again, planting basins, but the problem is the mulch. We need mulch in these fields. Probably here we've got a bit of mulching, which can actually control the weed. Any need of putting herbicides, as long as the mulch is enough. Of course, one thing is that the mulch, as the season advances, it may get decomposed. Again, you see the mulch, which may effectively control weeds in a maize crop. Again, mulch in cotton. Again, mulch in cotton. So let us now move to another form of mulching, solarization. This is the use of plastic. The plastic can trap solar energy, which can heat the soil or planting media, and this can kill weeds, weed seedlings, plant pests, and diseases. Previously, we were using ethyl dibromide, EDB, and methyl bromide. Probably EDB was banned. So we can probably use solarization in place of EDB. Or there could be other chemicals which can substitute it. So using the plastic, you simply lay them on the soil surface. When the light strikes these plastics, heat is generated, which is going to kill the weeds. Here we have got solarization in combination with the drip irrigation. So you use the plastic to retain moisture as well as to kill the weeds. Again, solarization in high value crops. This is in other countries. Again, solarization in maize. It has to be green maize probably. You can see this layer of plastic, which is supposed to control weeds. So in solarization, plastic mulches are stretched on the soil surface and buried into the soil on all sides to form an airtight seal. The most important properties for the plastics is translucency, reflectivity, and absorbance. This can influence soil temperature. Remember, the plastics can increase soil temperature, which kill weeds and probably some diseases. Apparently, clear or transparent plastic sheet is the best solarization tool. It can allow transmission of shortwave incoming radiation into heat. It is effective in trapping outgoing long wave radiation at night. So the heat which is created will kill the weeds. In contrast, colored plastics do not transmit incoming shortwave radiation, but they can absorb it and convert it into heat, which will also kill the weed seedlings. In a study done by Mashinga et al. In 1986, higher temperatures at 2 centimeter depth under clear plastic than black plastic in a cold season, June to August, were reported. However, the temperatures which were generated during this period were not high enough to affect the viability of weed seeds in the surface soil layers. So if you are using plastic sheets, they should be certain times during the season when this method is effective. However, Ngadze in 2005 was able to achieve maximum temperatures of up to 55 degrees Celsius and the minimum temperatures of 32 degrees Celsius. These effectively killed the weeds. Whether it was clear plastic or black plastic, no weeds survived. This could be done from August to November. What was noted was that there were high levels of ammonium nitrogen, nitrate nitrogen, calcium, magnesium. These were increased. Ammonia, gas, carbon dioxide, and other volatiles could have played a disinfection process under the plastic sheets. Obviously, this also killed the weeds. Now let us talk about gamma radiation. And this could be a very, very expensive system. Here we are talking of the bombardment of weed seeds in the soil using gamma radiation. Probably we need this in hospitals, not to use it for killing weeds. This is sophisticated and expensive equipment. And in Zimbabwe, we may not even talk of using it. And even other countries in the third world, because it's a very, very expensive technology. Electrocution using electricity, high voltage electrical current to apply to weeds. Yes, we may kill weeds using electricity, but the electricity is in short supply in Africa, and we may not afford to do this, although in other countries they may use high voltage, to kill the weeds. So this is the end of physical methods. You can see that with physical methods, probably mulching is more applicable. Solarization, yes. Flooding, some of these have got problems. So thank you. This is the end. So I will stop sharing. Okay, are you there?
Yes, Doc.
Yes, so we have covered the mechanical methods of weed control as well as the physical methods of weed control. And probably you could have seen the differences. But sometimes some textbooks or papers tend to mix these two. Any questions?
Doc, I thought maybe the live mulch will fall under cultural methods of weed control from other textbooks that I've read.
Yeah, it's still okay. I don't dispute that. As long as we are killing weeds with a technology which is applicable.
Which is applicable. What
Yeah,
about
either
the
we call it cultural or whatever we want to call it, as long as we can specify it.
Oh, I no. Negative in the event of an exam, you are required maybe to give cultural, mechanical, physical, and chemical. Then you start mixing cultural and physical.
In my case, I don't think I will just mark it. I mean, I know that out there, it's not probably as classified as we have done it. Probably we have just done it for convenience.
Okay.
But what is important is to know the actual process itself, whether it is applicable or not.
Okay, thank you very much.
Mm. In any case, when we ask you, I don't think you are going to ask vague things, which will confuse you. That is not the point, because we want you to identify something which is going to work to solve a problem.
Okay, I see.
Yeah. I know when we talk of cultural methods, these are a hell lot of things which we are talking about.
Yeah, and it tends to mix some of the mechanical, some of the physical, and even some
Yes.
of the.
Yes, you are right. I'm sure when we ask questions, we won't be vague. We are going to be very specific so that
Okay.
you are not misled.
Yeah, thanks for that, Doc.
Yeah, because we don't want you to spend time wandering around, So if we ask you about marriage, it's about marriage.
Okay.
Yes. Otherwise, what we will do, can we meet tomorrow?
Tomorrow I've got a busy schedule. After 2, I've got a meeting at work, so I cannot leave.
It's all right. What time do you want us to meet on Wednesday then?
Meet face to face?
Or face to face?
No, I'm asking, is it face to face or online?
It's virtual.
We can,
virtual.
Yeah, we can do this virtual.
I'm okay with the afternoons.
What time do you want?
We can even start at 2.
At 2, probably I will be teaching some other people, but I will be informing you. If I'm free, then we'll move to 2.
If you're okay with 3 o'clock, it's still fine.
Yes, 3 o'clock I will always be available.
So 3
Okay.
then.
But tomorrow I can inform you whether we are going to start at, is it 2 o'clock?
Are we meeting tomorrow?
Yeah, no, not tomorrow, sorry, Wednesday.
Okay.
So thank you very much. On Wednesday, I think I will give you some assignments so that you get familiar with the sort of questions which we set so that you practice.
Yeah, that will be fine.
Okay, thank you very much.
Thank you, Doc.
Thank you, Doc.
I'm going to record this. In fact, I'm recording it. And I will send you this, or you can access the YouTube.
Are you going to send the slides or the PDF?
Both.
Okay, Doc.
All is well.
If you search my name for videos under Google, you'll find all what you want.
Oh, okay.
Oh.
Yeah, instead of me, keep on sending to you on email.
Okay, Doc.
Okay, it's okay, fine.
Okay, thanks.
Bye.
Bye.
Bye-bye.
Bye.